All right, the next one we have to show the half angle formulas. We have to show that cosine of theta divided by 2 is equal to the square root of cosine theta plus 1 divided by 2. Alright, in order for us to do this one, we need to use the double angle formula for this one. And actually, we're going to use the same thing for the other ones. For the sine half angle, your teacher wrote it wrong on the worksheet for the sine. It should be 1 minus cosine, not 1 minus sine, but it's all good. So it should be 2 cosine squared theta minus 1, and also 1 minus 2 sine squared theta. Alright, so we're going to do the first one. So we're going to do cosine divided by 2 theta. Alright, so we're going to say, theta over 2. So we have cosine of 2 times theta over 2 is equal to 2 cosine squared theta over 2 minus 1. Cosine, so this is cosine of theta is equal to 2 cosine squared theta over 2 minus 1. So now we want to solve for cosine theta. So we have to take the 1 first to the other side. So we get 1 plus cosine theta is equal to 2 cosine squared theta over 2. Alright, next up, we need to get rid of the 2. So get rid of the 2 by dividing by 2. So we have 1 plus cosine theta divided by 2 is equal to cosine squared theta over 2. Now to get rid of the squared, we have to take the square root. So square root. So we have cosine of theta over 2 is equal to the square root of 1 plus cosine theta over 2, plus and minus. Plus and minus just depends on where the angle is at and what angle we're talking about. So now we're going to do the same thing for this time for sine. So we want the half angle formula for sine. So sine theta over 2 should be the square root of 1 minus cosine, not sine. It should read cosine. Your teacher had a typo. You should talk to him about it tomorrow. Oh, come on. Get out. Stop this shit. Okay. Yes, I know. Alright. So we're going to use this formula here now. So we know that cosine of theta is equal to 1 minus 2 sine squared of theta over 2. Okay? Right? It's the same thing we did here, except we're just going to skip this step. Go ahead and write it here. Alright, so now again we want to get rid of the 1. So it's minus 1 on both sides. So it's cosine theta minus 1 is equal to negative 2 sine squared divided by 2. Alright, so now you got to get rid of the negative 2. So you get rid of negative 2, divide both sides by negative 2. So we have cosine theta minus 1 over negative 2 is equal to sine squared theta over 2. Alright, so just like we don't want negatives in the bottom, we take the negative to the top. So multiply this by a negative. So we multiply this by a negative, all we're going to do is just flip it. So this becomes 1 minus cosine theta over 2 is equal to sine squared theta over 2. So just like we did last time, we take the square roots. So square roots. So we have sine of theta over 2 is equal to the square root of 1 minus cosine theta over 2. Okay. Alright, so that's it for that one. So now we're going to go ahead and do the other one. So cosine. So we have to find the one for cosine of pi over 12. So cosine pi over 12, we're going to use the half angle formula. So cosine of theta over 2, so we say theta is pi over 6. Alright? So this is going to be, so you know this is going to equal to the square root of cosine pi over 6 plus 1 divided by 2. Cosine of pi over 6 is square root of 3 over 2 plus 1 over 2. And you just simplify that. Now the same thing we're going to do for cosine of pi over 8. We're going to use the half angle formula again, so it's cosine of pi over 4 divided by 2. So once again, it's the cosine of pi over 4 plus 1 over 2. Cosine of pi over 4 is square root of 2 over 2. So it's the square root of 2 over 2 plus 1 divided by 2. Alright. Same thing for sine of pi over 12. We're going to use the half angle formula again. Pi over 6 divided by 2. Sine of pi over 6 is 1/2. So you have the square root of 1 minus 1/2 over 2. 1 minus 1/2 is 1/2. 1/2 divided by 2 is 1/4. So you have the square root of 1/4. Or just 1/2. I think. Alright. So then you can do the same thing for the next one. And that's pretty much it. Alright, so I'm going to do the next video for the other, for problem 3 in a little bit.